So we are going to do the graphs of secant and cosecant today. Remember that secant is equal to 1 over the cosine. So 1 divided by cosine, because they are what? Reciprocals. They are the reciprocal functions. Okay, so secant is going to be undefined when cosine is equal to 0. Because if you do 1 divided by 0, okay, that would be undefined. And we learned when we talked about the tangent and the cotangent yesterday, that means the graph is going to have vertical asymptotes there. So the vertical asymptotes arise whenever you are dividing by 0. Okay? And then secant is going to have the same period as the cosine, which you guys remember what the period is for the parent cosine function? 2 pi. Okay, and then we also know that the sine and the cosecant have a similar relationship. Okay, so the sine and the cosecant are also reciprocal functions. Okay, and they're going to have no absolute maxima and minima, so the amplitude is undefined there. But the A value does affect local max and min values. Okay, so remember, if it's the local max and the local min, that just means it's the minimum value in that area. Okay, so it's not the highest point out of everything. It's not the lowest point out of everything. Okay, so in this chart here, I know it looks like a lot. There's actually a few things on there that are not going to be on the graph, but it's used to help illustrate how you're going to remember how the values go. So for the secant, you have this dashed line here. This is not going to be part of the graph. Okay, so we're not going to graph that part. The reason why it's helpful is because we know that the secant is 1 over the cosine, and this line right here is the cosine of x. So the reason why they put it in there, the reason why I kept this image is because, remember, at cosine, we start at 1. So at 0, we're at 1 with cosine. That's going to be its reciprocal. Okay, so these functions that we graph for cosine are going to appear on our graph for the secant. Okay, and then the cosecant is 1 over the sine value . Okay, and then again, this part here, this wave, this is the sine wave. So normally when we start at sine, we start at 0, 0. Okay, and then we go to the maximum, 0, minimum, 0. Okay, so we're going to use those patterns to help us graph. So because we're going to use those patterns, the first thing we're going to do, we're going to start with sine, because I like sine better. Do you guys have a favorite trig function? Yeah, I don't know why, but I like the sine better. Secant's your favorite? Yeah. So remember when we did our chart for the sine, we started at 0. Do you guys remember what the last x value was? 2 pi. Caleb, put the calculator away. Okay, so 0 to 2 pi, and then what goes in the middle? Pi. And then halfway, pi over 2. And then halfway, 3 pi over 2. Okay, now for the sine values, we started at 0, we ended at 0, halfway was 0, max, and then the min. So that part's all reviewed. What we're doing today is the cosecant. So we're taking our values and we are doing 1 divided by the sine. So, sorry, I'll give you guys a second. Get that right down. All right, so all we have to do for these is 1 divided by the sine value. So if I do 1 divided by 0, what do I get? Undefined. So I'm just going to write UND, undefined. Okay, and then Jack D, if I do the reciprocal of 1, what's that? 1. Okay, and then Alex, if I do 1 divided by 0, what do I get? Undefined. So I'm going to write that again. And actually, let's just write it here as well. And then Bella, if I do 1 divided by -1, what do I get? Yep. Okay, so this is going to be part of our pattern. So we're going to be using the x and we're going to be using the cosecant. So like we did before, remember how I made those kind of those tables for you? So you know where you start, where you end, and how those go? We'll do the same thing with this. Okay, so we'll do x and we'll do the cosecant of x. Okay, so you're always going to start with 0. We aren't going to do any phase shifts. So with x, we're going to start at 0. We're going to end at the period. And then we're going to go halfway. And then, of course, we do the half of the half. Okay, now because sine always starts at 0, that means for the cosecant, this is always going to be undefined. At 0, at the halfway, and at the end, wherever our period ends. Okay, we got 1 and -1. That corresponds to the a value. So your a value would be in front. Okay, so we get 1 there. That's the a value. And then -1 would be the opposite of a. So you're going to use this chart to help guide you. All right, and then we're also going to make a chart for the cosine. All right, so we'll do x. We'll do the cosine of x. Okay, so again, just same thing we've done before. We go 0 to 2 pi, halfway's pi. Half of that's pi over 2. Half of that's 3 pi over 2. All right, and then Allison, for the cosine at 0, where are we? 1. So if we start at 1, we end at 1. And then Charlie, it's halfway in between. Oh, yeah, okay, so you start at the max, you end at the max. Do you remember what's halfway in between them? The minimum. So what's our minimum going to be? It'll always just be the opposite of this. Yeah, yep. So if your max is 1, the opposite will be -1. Yep. And then what happens halfway in between those two? 0. Yep. So you have a 0 here and a 0 here. All right. I'm going to give you guys a moment to write down. I want you to write down what the secant's going to be based on what we did here. Okay, so 1 divided by the cosine. So I want you to write those down in your table. And then if you think you can do your basic table, that's great. Okay, so Heidi, what do we get for the first one here? Yep. All right, and then Nihal, what do we get for the second one? Undefined, great. Blake, what do we get for the next one? -1, and then Nolan after that. Undefined, and then it's always if you start at 1, you're going to end at 1. Okay, so now let's make the standard table. Okay, so if you have x, and then you do the secant of x, okay, we're always starting at 0, so that's pretty nice. We're always ending at the period, and then we're doing halfway, and then we're doing half of the half. I just don't write that down. Okay. Quarter. If you want to write it down, you can do that. All right, so 1, do you guys remember from what we did over here what value that's going to be? It's going to be the A. So we're going to start at A, we end at A. That A is going to be in front. So it's going to change depending on what our values are. And then, so you had 1 and 1, max, your max of what you had for cosine. Okay, and then this is the opposite. So you start at A, you end at A. Halfway is the opposite of A. Okay, and then we have our 2 undefined values that are in between. Undefined and undefined. Okay, so a few things that we need to know. Anytime you have something that is undefined on the graph, that is going to be a vertical asymptote. Okay, so anytime you have something that is undefined on the graph, that is going to be a vertical asymptote. And then you are going to be writing out an equation for the asymptotes. So we're going to write that below here. Okay, so anytime you're writing out the equation for the asymptote, it's going to be kind of similar to what we did for the x-intercepts. You're going to choose one of the asymptotes. Okay, we can choose that from the chart or the graph. And then let's see how often our asymptotes occur here. So this one is pi over, negative pi over 2, pi over 2, 3 pi over 2. Here we have them at 0, pi, negative pi. What's the spacing between them? Pi. Now, the significance of that is based on the period. So to find the period for these, you are going to do the period is equal to 2 pi over b. For the parent functions, your b value is just 1. Okay, for the parent functions, your b value is just 1. So the period would be 2 pi. So if our period is 2 pi, but the asymptotes occur every pi, we would say they occur every half of a period. Okay, so in the equation, our asymptote is going to occur every, you can write either period divided by 2, or you could write period times a half. And then just like we did yesterday, that'll be times n. Okay, so I'm going to write this both ways throughout. So the period divided by 2 times n, or just 1/2 of the period times n, those will be the same thing. Okay, so for these, your a value is 1, but your a value is going to change based on the graphs that you have. So when you have an a value, whatever that is going to be your local minimum. And the reason why we call it local is because it is not the lowest value in the entire graph, but it is going to be the lowest in that area. So it's going to be this value on the graph, which we marked off. This would be a local minimum. This would be a local minimum. And then we also do the opposite of A, okay, which is negative A in this case. and that's going to be our local max. So if you have a local max, it's a parabola that's opening downward. Okay, and you are going to see those. In your chart. Oh, we labeled this one as the cosine. We didn't label this one as the sine. Let's do that to make it the same. Okay, so you are not going to be, what I highlighted in yellow there, you are not going to be including that on your graph, but you are going to be thinking about that as you make your table. So we're going to use the secant or the cosecant as a guide to graph the function. You are going to identify the period and make a table with 5 values. You also need to identify the asymptotes. And again, that will be an equation just like we were practicing with our tangent and our cotangent. All right, so the first thing we're going to do is find the period, okay? For the secant and cosecant, the period is 2 pi over b. I like to identify my b value right away. You can always find it in front of your x. Okay, so if my b value is 1/2, okay, if I do 2 pi divided by 1/2, Silas, what's that going to simplify to? 4 pi. Great. So that's going to be my period. So as soon as you figure that out, I recommend step 2 being your table. Okay, so as soon as you have that, let's go ahead and do our table. So for the table, we have x, and then this one is called g of x. Okay, and then sometimes I just remind myself if it's secant, it's 1 over the cosine. That way I know what I'm going to be using. So I'm still going to start at 0. Now I end at my period, which is 4 pi. So half of that would be 2 pi. Half of 2 pi would be pi. So now I'm counting by pi's. 1, 2, 3 pi, 4 pi. Okay, you really can use this chart, which is very handy. Okay, so you can find your A value. Your A value is always in front. Okay, so in this case, your A value is going to be 1/2, just like B. Okay, so at 0, we're at 1/2. If we start at 1/2, we end at 1/2. Okay, and then halfway would be -1/2. Okay, at pi, that's where we get an undefined value. At 3 pi is the other undefined. Now remember what those mean. Anytime you have something that's undefined, what that tells us is that's where the vertical asymptote is going to be on our graph. So let's go ahead and put those in. All right, so then at pi, we're going to put in the vertical asymptote. At 3 pi, we're going to put the next one. And now our pattern's established. So every 2 units, I'm going to put in an asymptote. Every 2 units, I'm going to put in an asymptote. Okay, so when you are identifying what your asymptotes are, okay, you are just taking one of your vertical asymptotes, okay, and then you can do the period divided by 2 times n. So let's go ahead and calculate that for this one. So the first vertical asymptote occurs at, and you're using the x values, so it occurs at pi. And then the period is 4 pi divided by 2 times n. So we just have to simplify that. So it's pi plus 2 pi n. And really for vertical, you should have your x equals with it. Okay, you could also do 3 pi plus 2 pi n. That would be fine as well. You can just pick either one that's in your table. Or if you want to pick one on your graph, you could do negative pi plus 2 pi n. All right, now here I'm at 0, 1 half. Okay, look at the way that these are labeled. So if this is 2, I'm going to say halfway is 1. So half of that would be 1 half. And then your vertical asymptotes are the bounds for your parabola. So that's what you're going to use to help you decide how narrow or how wide it is. And those are going to vary just depending on what your values are. So I have negative 1 half. One thing to keep in mind is you are never going to cross the x-axis. Your arrow should always be going away from that. And then we still have to graph this half of 1 here. Okay, and then we are still going to continue this pattern. All right, and then we just have one more to go. So what I want you to do for B is I want you to identify A, B, and the period. Go ahead and do that right now. Okay, so your A value is always in front of your trig function. Your B value is in front of x, so your A is 2, your B is 1. So when you go to calculate the period, you have 2 pi divided by 1, which is 2 pi. Remember, as soon as you know the period, you can start to set up your table. Okay, your table is always going to start when x is 0. So if I start at 0, I'm going to end at my period, which is 2 pi. I'm going to do halfway and then half of the half. Okay, so your A is 2, your B is 1. You calculated the period at 2 pi. So then we're ready to go to our table. You always start at 0, you end at the period, find the halfway, the half of the half. That's what you count by. 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, simplifies. Now remember, for g of x, this is 1 over the sign. So we know that the sign at 0 is 0. That's why for the reciprocal, it becomes undefined. Okay, so you have undefined, undefined, and undefined at the start, at the end, and at the middle. And that's where you're going to put your vertical asymptotes. Okay, now your A value is 2. The opposite would be negative 2. When you do your graphs, you are going to have to label the x-axes just like we have been. And then as soon as you know where your vertical asymptotes are, you can feel free to put those in. If you want to use a highlighter, that's fine. But any vertical asymptote is going to be a dashed line. And now our pattern is going to be set. So we can see these occur every 4 units. And then when we're writing our equation for the asymptotes, we're always just going to pick one, and then we add that to half the period times n. Okay, so the first one's at 0. So if I do 0 plus 1/2 times 2 pi n, what happens when you multiply 2 pi by 1/2? Yeah, you just get 1, right? Okay, so this is going to simplify. This is going to simplify to pi n. Okay, and then when you're graphing these, remember, you have to keep this away from the x-axis. So pi over 2, you're at 2. At 3 pi over 2, you're at -2. And then these are always going to alternate. Okay, so they're always alternate between opening up and then opening down.